Hello guys, welcome to my class. Today we are going to learn how to analyze and design a steel truss. Concrete design and steel design is same. Is difference between in the concrete design we use the material as concrete and the steel design we use steel. Rest is the same. Okay, so at first open STAAD Pro. Click on new project, click on truss. Okay, select the truss option. Length unit same as the concrete design, meter and kilonewton. Okay, then click on next, then click on add beam, then finish. Okay, we are designing this truss. Okay, you can see it is distance 2 meter 4 pay, height is 3.6 meter, and this is in nodal load. Okay, and this is pin support and this is fixed part. Okay, so we are going to front view and we are going to change the grid. Go to edit, spacing is 2.4 in the x direction. See, 2.4 because this distance is 2.4 and the upper distance is 3.6, so it will be easy for us drawing. Upper is 3.6. okay, now zoom it a little. Now our distance is 2.4 is 4 into 4. Okay, and upper is 3.6 in the middle. So start here, 1 2 3 4. Okay, now our base is complete. Now press Ctrl from going to upper and not linked this, but you can link this. Okay, in the middle and end here. Now switch off the snap node grid. Now this is our figure, and now join the nodes as per our figure. Middle is perpendicular and these two nodes will be joined. Now same as the concrete design, go to add beam, add the nodes. Now add the nodes. Okay, now this portion is complete. Now we have to add this point to this point. Okay, you can add this node to this member of the middle by two options. You can break the member into two parts, or you can, as you can go to member, you can insert the node in the middle, or you can add the member in the perpendicular. Okay, I am going to add the beam as a perpendicular. Or you can insert the node. For that, select the member, go to right option, click on insert node, click on add midpoint, and OK. Now it is a midpoint. Now it is the same. Right, click on the right on the beam, insert node, add midpoint. Now in the midpoint a node is created. Now go to add beam and just add the beam. Now our figure is complete. Now we have to give the support. For that, go to support page, click on create. Now we have to add the pin support and the fixed part it will release in the fx and mz. Okay, then add it. Now according to our figure, the fixed part will go on the left and pin will be right. This is pin, go to the right, click on assign to selected nodes and assign, and yes, and fixed part will go to the left. Similarly, assign to selected nodes, assign it, yes. Now have to go to the member property. Okay, now go to the section database. Okay, now this still select your code, and I'm going to select Indian. Okay, now I'm going to select angle. You can select any angle. I'm going to select the up one. Material is steel. Add it, close it. Now it goes to the total structure. So select it, select beam cursor, select total beams, click on assign to selected beams, assign it, yes. Okay, now go to the load page, go to load case detail, click on add, click on date, title, date, add it, close it, click on date, add, click on self weight, click on nodal load. In the FY gives 8 kilonewton in the 3 upper nodes, so we give -8 to FY, then add it, close it. Self weight goes to the total structure and nodal load goes to the upper 3 node. Press Ctrl from your keyboard. Okay, then assign to selected nodes, assign, yes. Now our load has been given, click on load to scale it. Okay, now we have to analyze it. Go to command, analyze, perform analyze. Okay, analyze, run analyze. Analyze take some seconds. Okay, this is complete. 0 error, 0 warning, 0 nodes. Okay, perfect. Click on done. Now you have to design it. Go to design, steel design, select your code. I'm going to select IS 800 as an Indian. Click on select parameters, select your parameters. I'm going to select FYLD. Okay, select yield strength of steel. Now select it. Okay, now define the parameters, 25,000. Okay, add it, close it. It goes to the total structure, assign to view, yes. Now go to comments, add the check code for us, check the adequacy of member based on specification of desired code. Okay, I have select a angle. Okay, now if for the total structure, but we have to give the star member as the member have to resist the load. It may the angle have been changed, or member property can be changed, so that's why we go for the check code. Then go to the member takeoff. It provide a tabular report of the total length and width of section used in the structure on a member by member basis. Okay, add it, then go to the select, Now what is select? Select list weight section size based on specification. Now the specification size weight gives it. Add it and take off. Provide a tabular report for the total length and width of all section user in the structure. Okay, add it, close it. Now it will also go for the total structure. So click on assign to view, assign yes, steel member take off, assign to view, assign yes, select, assign to view, assign yes, select, take off, steel take off, assign to view, assign yes, then again analyze it, comment, analyze, perform analyze, no print, okay, then analyze, run analyze, save. Okay, there is no error, no warning and no notes. So our analysis and design is perfect. So you can go to the output file. This is a steel design, okay, for different member. Steel takeoff, steel design. You will see the angle. It says pass, pass, pass. Okay, not fail. Is the result. Close it. You can check any member fails. If any member fails, for that go to select by specification, all fail beam. You can see no beam failed for steel because we selected the select option. Okay, it provide which the angle or property can take or resist the loads. So we go to the post processing. Okay, now you see the displacement. Okay, you can go to the axial force. The force is on the upper side and these two sides. Shear on Y, shear on Z, torsion, you can see, then bending Y, you can see the beam stresses, see upper two side and these two side, then see the reaction for two supports. This is 12.81 kilonewton and this is 12.81, same. Okay, you can see the animation for deflection, apply. Okay, see, because we give this a pinned and fixed part, so you can go inside in other side, or you can go to the report, select what you need, or you can select all, click on OK. Now this is your output. Okay, all the output file has been given here. Okay, so that's it. That's how you're gonna design and analyze a steel truss or steel frame. So keep subscribing on my channel, and if you any doubt or if you want to know something, then you can comment on my video. I will get back to you soon. So thank you for watching my video.